Let me know if you get stuck, okay? Also, listen, first you need to calculate the half-life has been given. You need to calculate the rate constant K. Okay. So for first order reaction, you can know the relationship between half-life and the rate constant. And then using this rate constant, you need to apply the integrated rate law equation and then calculate what percentage of the initial reactant. Okay, you need to calculate the final concentration of A. Okay, so there are two parts. First of all, calculate the rate constant and then use that rate constant to calculate the percentage of initial reactant that will react. That means final concentration of the reactant after 20 hours. Rifat, Hanifa, and Nawal, you guys need some more time.
Sir, do we have to
Yes, okay. Yeah, who was asking something? Rifat, yeah.
Do we have to convert the 20 hours or just?
Yeah, sure. Like you will get the rate constant in terms of what? Second inverse, right?
Yes.
Right. So in terms of second inverse, so you need to convert this 20 hours to seconds, or other if this rate constant is huge, then convert the second inverse to hours, R inverse. Okay. Don't change the, like you just change this second inverse to hour inverse. That's it.
Okay.
Okay. You can choose to convert any one of it, either the hours to seconds or seconds to hour. Okay, guys, can you please send me whatever you have done till now, Hanifa and Rafat? Whatever you have done till now. Yes, Hanifa and Rafat, please send me now whatever you have done till now. The log part will need some help, okay? So send me whatever you have done till now, and I will proceed further. Okay, that's the answer. So you did not convert anything. रिफत ना आपने सेकंड में कन्वर्ट किया ना आपने उसको आवर्स में कन्वर्ट कुछ नहीं कन्वर्ट किया आपने okay let us see okay हनीफा okay okay fine स्टार्ट आप लोगों ने तो ठीक किया है okay starting is fine so there are two equation that you need to remember for this that we know that t half is equal to tell me what refer t half is equal to 0 point for first order reaction t half is equal to tell me Hanifa
0.693 by K.
0.693 divided by K. So I can write K is equal to 0.693 sorry not 5 divided by the t half okay and we also know what is the integrated rate law equation for the first order reaction K is equal to what can I write
2.303
yeah correct and also K is equal to 2.303 divided by the time taken multiplied by log of initial concentration upon the final concentration okay so we don't know this part right we don't know this part okay now in place of K I will write this also first I will convert t half is equal to what 20 into 20 hours has 60 minutes into 60 seconds right so this will be equal to 6 is the 36 36 to the 72 and 1 2 3 zeros right 7200 seconds I can also write this as 7.2 into 10 to the power how much 3 seconds okay so now in place of K I will write this 0.693 divided by 7.2 into 10 to the power 3 seconds correct guys yes or no please tell me
Yes.
now oh sorry this was t half no this is not t half na my bad here you will be having 5 into 10 to the power 4 seconds here you will be having 7.2 into 10 to the power 3 seconds into log of a naught upon a now let us see log a naught upon a will be equal to this will go there 2.303 multiplied by 5 into 10 to the power 4 divided by 0.693 into 7.2 into 10 to the power 3 you need to solve this one right okay so 10 to the power 4 10 to the power 3 this will be 2.303 into 5 divided by 0.693 into 7.2. This will be into 10 also. Correct? यहाँ तक सही है? कोई दिक्कत? No problem, right? Okay. Can you calculate this value? How much will it be? Let me just see. That is almost 2.303. Okay. Did I miss something? Wait a second. Oh, this will be 7.2 into 10 power 4. Oh, नहीं. अच्छा ये 3 0 होंगे ना यहाँ पे. Wait a second, please. This will be 10 power 4. So this will cancel both of these things. This 10 will not be there, okay? This 10 will not be there. So this will be छूट रहा है क्या? Guys, I did a mistake. Just a second, let me correct it. This will be in the numerator, right? My bad, guys. Okay, so this value is coming out to be, this is having 11.5 and this is 4.9. Okay, so when I divide both of these things, 4.98 divided by 11.5. 4.98 divided by 11.5, right? Coming out to be 0.0433. Okay, now this value here, log of a naught upon a is equal to 0.0433. Now, as you can see, you have not been given any log values, right? So what we need to calculate, this 10 to the power a naught by a will be equal to what? 10 to the power 0.0433. How to calculate this value? Any idea? Tell me, guys. How to calculate this value? Yes, Anifa, you don't know? Okay, see. Whenever you have decimals now, what you should do here, you should write it in this form. 10 to the power, I can write this as how much? What is the number? 1 minus something, right? 1 minus x will be equal to 0.043. So x will be equal to 1 minus 0.043. Can you calculate what is x? This is equal to 0.957. Just a second.
0.957.
Yeah, 0.957, right?
Yes.
Just a second. Oh, okay, fine. We have here, okay, we don't need this actually. 0.0957. That will be 10 to the power minus. And is this value near to anything? 10 to the power 0.957 is approximately equal to what? Tell me. एक log का value होगा ना, which will be very near to 0.957. You remember the log values?
3.
Log of what? What, Anika?
3.
No. What is log 9? What is log 9?
Sir,
Are
0.96.
0.96, right? So it is very similar to what? 0.957. I can write this as what? This is equal to 9, right? This is equal to 9 because log 9 is equal to 0.96. So 10 to the power 0.96 is equal to what? 9. दिख रहा है आप लोग को? Yes or no, please tell me. Can all of you see that? ठीक है, अब यहाँ पे देखिए. I can write this one as 1 minus 0.957. Correct है? Yes or no, please tell me.
Yes.
Right?
Yes.
Now, what I can also write this as? I can also write this as 10 to the power 1, correct? Divided by
Yes.
10 to the power 0.957. Correct? Yes or no, please tell me.
Yes. Yes.
I can write this as 10 upon 9. Can all of you see that? Yes or no, please tell me.
Yes, sir.
Right? अब देखिए. A naught upon A is equal to 10 upon 9. That means if the initial concentration, see, this is very important, okay? If the initial concentration was 10, then how much reactant will be left? 9. That means reactant left after 20 hours is 90%. I can say yes or no, please tell me, guys. Correct? You will not say 9, okay? Why? Because they have not given us the initial concentration. Please look here. They did not give us any initial concentration. They said that what percentage of the initial reactant will react in 20 hours. We have got the fraction of the initial concentration divided by final concentration. And from here, you can relate that if initial was 10, final is 9. That means in percentage wise, 90% will be left. Yes or no?
Yes.
What percentage of the initial reaction will react in 20 hours? React कितना करेगा तो reactant that will react in 20 hours is equal to 10%. Yes or no, please tell me.
Yes.
Okay, please write this down. Can I move on? Yes or no, please tell me. Okay, let me know when you are done, okay? Is Hanifa and Nawal done?
Yes.
Yes, okay. Right, next. Collision theory. Okay, so first of all, let us understand what is collision theory, and then we will write the theoretical part of this complete thing. Okay, so now what is collision theory? Collision theory, we've already looked when we started the law of mass action. In that, we saw that a reaction can happen only when reactants collide, right? Reaction happens only when reactants collide. Okay, so this is a very basic initial thing regarding collision theory. Collision theory says that reaction will happen only when reactants collide. Okay, now if I have, let us suppose, two reactant A and B. I have A reactant here, I have B reactant here. Okay, now there are some different ways by which they can collide with each other. So there is a way in which they can collide completely head on. Okay, they can collide completely head on collision. What is happening? Just a second. Okay, so in this collision, what is happening? Red and green, they are colliding very directly. Now, another is what is happening? These both of them are colliding tangentially. Okay, and there will be one collision in which one of the reactant is here and the other reactant is here. Okay, so they are just touching each other, nothing else. I hope you can see that this head-on collision, it will be very effective, and this is going to give you product. This tangential one, they are going to just touch each other and they are not going to give product. Okay, this is not useful and this is also not useful. Now let us also imagine what happens if, let us suppose, we have two reactant molecules like this. They come into contact, and they just touch like this very slowly. They touch very slowly. Then also what will happen? The reactant will not form products because they're not touching with enough energy. They're not touching with enough energy. So first thing is what? Reaction will happen only when reactants collide. That is the first condition. Second is that they should collide in a correct orientation. They should collide in the perfect orientation. The next thing is that their energy should be high. Their energy should be high, as in they should be able to form products, and collision itna तेज का होना चाहिए that they should be able to form a completely different product. They should not just touch each other. Okay, all of you got this? Yes or no? Please tell me about collision theory.
Yes.
First thing is that reactants should collide in proper orientation and with enough energy. Okay, so we'll write few points now. Please write with me. Please write with me. There must be collisions taking place between reactant molecules but every collision is not fruitful. is not fruitful. Only small number of collision only small number of collision are effective and bring about chemical change. Okay, right, next. The minimum amount of energy, the minimum amount of energy required by reactant molecule for effective collision is called threshold energy. Okay, that means if the energy is less than the said threshold energy, then the reaction will not take place. The energy of the reactant molecule should be either equal to threshold energy or more than threshold energy. Okay, so this was the point regarding the energy. Write the last point. There must be proper orientation between the reactant molecules for effective collision. Okay, so what is the conclusion? As a header, you should remember only 3 points. Necessary condition for effective collision. The necessary condition for effective collision is number 1, threshold energy. Second, proper orientation. All of you done? Yes or no? Please tell me.
Yes, sir.
Okay. Right, next point. Maxwell-Boltzmann distribution. Maxwell-Boltzmann distribution. Okay. Now, first of all, it is a graph. Now, this is a graph between the kinetic energy of the molecules. Okay. And in the y-axis, we have the number of molecules. Okay, so the graph looks something like this. Here, generally, we have kind of a straight line. Then there is a bit of curve like this. I think I cannot pull this off. I have to trust my hand. ऐसा नहीं होता, लेकिन it's like something more like I really can't make this. Yeah, something like this. Okay, you get an idea. Okay, now I want to ask you a question. I have 3 points: point A, point B, and point C. My question is, where is kinetic energy maximum? A, B, or C? Please send the answer on chat. Yes, Hanifa, that is right. Nawal, what do you think? Yeah, very good. Okay, kinetic energy is maximum at C point. Now, what this distribution is? Distribution is about the kinetic energy that is present when you have many millions of reactant molecules. That means very less reactant molecule will have zero kinetic energy, and as we are moving above, that means we can see that as we are going to increase the kinetic energy, when the kinetic energy increases, more number of molecules are having this kinetic energy, and then this is the point. Most of the elements are having this kinetic energy. Most of the elements are having this kinetic energy. But for the reaction to occur, only a fraction of these molecules will be able to react because the threshold energy. Okay, so let us suppose that this is your threshold energy. Okay, so very few molecules or fractions of molecules have energy that is greater than the threshold energy. Okay, please write fraction of molecule have energy greater than threshold energy. Okay, only fraction of molecule have threshold energy. Okay, now let us see. There is a question which was asked, and it said that large number of particles have energy greater than threshold energy. Still, the reaction is slow. Why? Okay, what did it say? They said that now if we are having particles, like large number of particles which are having energy that is greater than threshold energy, that means the reaction should be fast, right guys? Yes or no? Please tell me, Nawal and Hanifa. If you have a large number of molecules with energy greater than threshold energy, then what is expected? Expected is that the rate of reaction will be what? High. Yes or no? Please tell me. Reaction will be fast.
Yes, sir.
Yeah. But still what is happening? But still the reaction is slow. Okay, this is what it is observed. Okay, हम ये नहीं बोल रहे कि हमेशा ऐसा होता है. They are saying that for a particular reaction this happened. For a particular reaction this happened, that the energy was greater than threshold energy, but still the reaction was slow. Why is that? This is not a, what I can say, फंडामेंटल स्टेटमेंट और यूनिवर्सल स्टेटमेंट नहीं है कि अगर ग्रेटर बहुत ज्यादा पार्टिकल्स के पास अगर हाई एनर्जी रहेगी तो हमेशा ही रिएक्शन स्लो होगा. ऐसा नहीं है जरूरी. They saw that the reaction was slow. Then why it will be slow? Because why it can be slow? There are only two conditions. This is there, threshold energy is there, but proper orientation must not be there. That is why it is slow. All of you got this? Please tell me.
Yes, sir.
आप लोगों को समझ में आया सवाल क्या पूछना चाह रहा था? So they were actually testing you that you should know what is the condition for effective collision. एक तो condition fulfilled था threshold energy, but the reaction was slow. That means orientation was not good. Please write it is due to improper orientation of reactant molecules. Okay, right, next. Some remarks regarding the Maxwell-Boltzmann distribution. Right, number one. Maxwell-Boltzmann distribution is a bell-shaped curve between number of particles and kinetic energy. It shows that very few particles have kinetic energy greater than threshold energy. लिख लिया आप लोगों ने? Yes, Rifat, Hanifa, Nawal,
Yes,
done?
sir. Yes, sir.
Okay. Right, next. Activation energy. Okay, activation energy. Please write. See, whenever you have reactant molecules, each and every particle in this universe, they have some amount of energy. No one is in zero energy. Okay, they have some kind of potential energy or some kind of vibration will always be there. That means the threshold energy will be what? A few steps. Like it will not start with the threshold energy. The reactant, they have to achieve some kind of energy. Okay, if the threshold energy is, let us say, 5 joules, they have to achieve an energy of 5 joules in order to react. That does not mean that they require the complete 5 joule from outside, because each and every molecule, they will be having some kind of kinetic energy, and there will be like some molecules with 1 kinetic energy, some molecules with 2 kinetic energy, some molecules with 2.5 kinetic energy. So the one molecule is going to reach 4 joules. The 2 is going to need 3 joules of energy. 2.5 is going to need 2.5 joules of energy. Okay. So this extra energy that is needed is known as the activation energy. Please write here. You will understand it more. Please write this with me. The minimum amount of additional energy required by reactant molecules to achieve threshold energy is called activation energy. लिख लिया आप लोगों ने? That means C. The threshold energy ET will be equal to the activation energy, which is the average the energy which is the average energy of the whole molecules. Okay, we have plenty of molecules. We will average the energies of each and every molecule. That average energy plus the activation energy, E act. Okay, so E threshold is equal to E average plus E act. Let me write this down also. Threshold energy. Average energy plus the additional energy to achieve threshold energy, that is activation energy. ये फॉर्मूला नहीं है, ये फॉर्मूला से आप लोग, ये डेफिनेशन है. ओके, this is the definition of threshold energy in terms of average energy and activation energy. This is not a formula. All of you done? Yes or no? Please tell me.
Yes, yes.
Okay, now let us write progress of a reaction. Now, in progress of a reaction, we have two axes. This is the reaction coordinate. Okay, or the progress of reaction is here, and here we have the potential energy. Okay, here we have the potential energy. Now, there are two cases in which we'll be dealing with progress of reaction. Let us look at the first case. In the first case, let us suppose the average energy of the reactant molecule is somewhere here. This is the average energy of what? The reactant molecule. Okay, this is the reactant molecules here. And they will need some kind of energy, okay, to do the reaction. So this is what? This is your threshold energy, and the difference between the reactant's energy and the threshold energy is known as activation energy. Okay? And then let us suppose that the product have a lower energy like this here. This is your product. Okay, so this line here, what does this denote? This denotes E average of the reactant molecules. Then this point, just a second. Yeah, this point here, this energy is known as what? Threshold energy. And then the difference between threshold energy and the average energy will be known as what? It will be known as activation energy. Activation energy. Okay, and the difference between the reactant molecules energy and the product energy is known as delta H, change in enthalpy. Now, in this case, you tell me the energy of product minus the energy of reactant will be positive or negative. क्या दिख रहा है आप लोगों को बताइए जरा. Product minus reactant. Whose energy is higher, product or reactant? Tell me. Whose energy is higher?
Product.
Whose energy is higher? Product की energy ज्यादा है. Please see.
Reactant.
Reactant की ज्यादा है ना. Who said product? Why product? Product is lower na in energy. See, this is the potential energy. This is the reaction coordinate. This is not energy. Okay, guys. This is not energy. This is reaction coordinate. Please remember that. Okay. Now, so if product energy is lower, reactant's energy is higher. That means final minus initial energy will be negative. And if this is negative, that I can say delta H is equal to negative. And when delta H is negative, this reaction will be what? Exothermic. That means it is going to give you energy. Okay. Next, moving on. The case where delta H is going to be positive. Okay, please see here. This is a reactant molecule. This is product. This is your threshold energy. This is your activation energy. This is the delta H. Here you can say E product minus E reactant will be equal to positive. Delta H is equal to positive. Reaction will be endothermic. Now, very important point. This particular state of the reaction, this particular state of the reactant molecules, this particular state of the reactant molecules. Okay, so both of these, why they are important, because you can see that this is the state or the configuration of the reactant molecules in which the energy is highest, and these state are known as transition state or activated complex. Or activated complex. Okay, write this down. जी लिखिए आप लोगों ने एसएनओपी में.
Yes.
Yes.
Okay. See, these diagrams are important. Okay, label diagram आपको बनाने आ सकता है 3 मार्क्स में भी. Write some remarks. Okay. And remarks number 1 point. When activation energy is high, if the activation energy will be high, the reaction will be obviously slow, right? Slow reaction will be there. Why? Because the activation energy is high. To achieve the activation energy, the reactant molecules, they are going to take a lot of time, and that is why the reaction will be slow. When activation energy is low, then this will be what? Fast reaction. Right, guys? It will be fast. The reaction is going to be fast in that case. Next point. If energy of product is greater than energy of reactant, in this case, it will be what? Product की energy ज़्यादा है. That means it will be what? Endothermic. Endothermic. Delta H इस case में क्या हो जाएगा? Delta H will be positive. When energy of product is less than the energy of reactant, this will be case of exothermic. And delta H will be negative. Right, next point. When the colliding molecules possess energy equal to activation energy the atomic configuration formed at this stage is called transition state or activated complex. Done, guys? Yes or no? Please tell me.
Yes, sir.
Yes. Okay. There is a topic that we have not done pseudo first order reaction, right?
No, sir.
Pseudo first, no ना, उसको लिख लीजिए एक बार. Let us suppose we have a reaction. Okay, if you remember somewhat of organic chemistry, you should remember that. Please don't write this. Okay, please don't write this now. If we have ester and add water to ester, I am going to get carboxylic acid plus I'm going to get alcohol. Okay, carboxylic acid and alcohol. Let us suppose we have some ester, but this water is in a tank. It is very large amount of water. Okay, so this water is in excess. ऐसा मान लीजिए आप, one tank, 1,000 liters of water is already present, and we have 1 molar ester. Okay, all of you don't have any problem with the conditions, right? This can happen. 1 molar concentration of the ester, and or rather I should say that let us suppose you have 10 moles even. Okay, what do we have? 10 moles of ester. And water is 1,000 liters. Okay, water is 1,000 liters. They are going to react with each other and they are going to form carboxylic acid. Water is also a reactant. Okay, water is also a reactant. अच्छा एक बात बताइए आप लोग, what will happen if I change this concentration of 1000 ml to 1005? Is it going to change the rate of reaction? Tell me. This small change that I have done from 1000 to 5, is it going to affect the rate of reaction? Yes or no? Please tell me. Hanifa, Nawal, and Rifat, what do you guys think?
Yes, it will.
How much will it affect? Any considerable amount? Significant amount? 5. ऐसे डायरेक्ट नहीं होता है ना, आपको ये तो पता होना चाहिए, डायरेक्ट नहीं होता है। ऑर्डर ऑफ रिएक्शन वगैरह सब आपने पढ़ा है, कई बार ऐसा होता है ना। आप एक बात बताइए कि 5 ml हमने इंक्रीज किया, डबल भी नहीं किया हमने। ओके, so what change can you see? This is a very minute change. Also look at the ester molecules. Ester is how much? 10 moles. Even if you are having 10 moles of water, that will be enough for esters. ये 1000 लीटर से आप 1005 कर दीजिएगा, कुछ फर्क नहीं ना पड़ने वाला है, because only 10 moles of water is enough. After 10 moles, whatever you are adding is what? It is excess. Yeah, for sure. If water you were increasing from 1 mole to 10 mole, then it would have some effect. But after 10 mole, everything is excess. Whatever you are increasing, is it reacting? First of all, tell me that yes or no. Is that extra, whatever you have added, is this going to react? No, na? Because we have already achieved what is the optimum amount of water required. So whenever a molecule is in, whenever a reactant species is in excess. For example, if water is in excess here, now this water is, if you are going to increase the concentration of water, when it is already in excess, it is not going to affect the rate. Because why it is not going to affect the rate? Because it is already in excess. And now whatever was required for the reaction, that is already present. Whatever we are adding is extra. And now whatever we are adding is extra, that is not going to even form the product. And if it is not going to form the product, then how is it going to increase the rate of reaction? Okay, so the reactions in which these you can see are what? These are not truly first order reaction. In this, you can say water is in excess. That means the concentration, if you are going to change it, it is not going to affect the rate of reaction. That means the rate of reaction is only affected by the ester molecule. The H2O molecule here, it has no role in the rate of reaction when it is in excess, Okay. So now this is not truly a first order reaction, but because one of the molecule is in excess, this becomes a first order reaction. And when it becomes a first order reaction, then we say that these are what? Pseudo first order reaction. These are originally or truly not first order reaction, but they become first order reaction in the presence of a reactant species in excess. So please write with me the reaction which is not truly first order, but under certain conditions. And the condition that you have to study is when one reactant is in excess. It becomes first order. Hence, the reaction is called pseudo first order reaction. The example you can write ester plus water giving you carboxylic acid plus alcohol. This water is going to be in excess. A simple ester molecule is going to be CS3, C double bond O, O, and then again a CS3 here. Okay. Plus H2O. First of all, you are going to get carboxylic acid with CS3 C double bond O, OH plus CH3OH. Okay, so for this, the rate of reaction, it is equal to the rate constant K into the concentration of ester only. It never depends on water molecule at all. Okay, we don't even write this ester, and we don't even write this water molecule here. So order is equal to 1, and the molecularity for this reaction will be equal to 2y, because ester and a water molecule, they have to collide. And whenever we see the number of reactant species which are colliding to form the product, that means we are talking about molecularity. Okay, even though water is not going to affect the concentration of water, if we increase or decrease it, it is not going to affect the rate of reaction. Please remember that if a reactant is in excess, then the rate of reaction does not depend on that reactant. Then guys, yes or no, please tell me. लिख लिया
Yes,
आप लोगों ने? चल. Right, next. Temperature dependence of rate. First of all, you all will tell me, don't write anything. Please tell me. On increasing the temperature, velocity of particles will increase or decrease. Tell me, guys. If I increase the temperature of the container in which the reactant molecules are present, then tell me the velocity of particles will increase or decrease or remain same. I'm increasing the temperature. Please tell me fast. क्या होगा, guys?
decrease.
The velocity of particle is going to increase, right? इसने decrease बोल दिया. Decrease क्यों बोला? And why decrease? नहीं decrease क्यों बोला था आपने? मतलब जिसने ही बोला था. Temperature आप बढ़ाइए ना किसी भी चीज का. Then it will run faster, right? It will get the energy. It will get the kinetic energy from that heat. Okay. Now, if the velocity of particle is going to increase, that means I can infer that more collisions can happen. Correct? Yes or no? Please tell me, guys. Yes or no? Now, if there is more collision happening, the chances of effective collision increases. And if the chance of effective collision increases, that means the rate is also going to increase when I'm going to increase the temperature. When I'm going to increase the temperature. All of you got this? Yes or no? Please tell me that. Yes or no? Please tell me.
Yes.
ठीक है, सबसे पहली बात. And also this is what it is, just a qualitative analysis of the temperature dependence. Okay, so we are not dealing with numbers, we are just saying that. Please write with me. According to collision theory, the rate of reaction will increase with increase in the frequency of effective collision. On increase in temperature, the velocity, or we can also write kinetic energy of reactant molecules also increases. This will lead to more number of effective collision, which will increase the rate of reaction. लिख लिया आप लोगों ने SNOPCL में?
Yes, sir.
Yes.
Okay, right, next. देखिए एक चीज आप देख लीजिए. Before that, this is our Maxwell-Boltzmann equation. Okay, this was sorry. This is Maxwell-Boltzmann distribution curve that I'm going to draw here. Now, in this Maxwell-Boltzmann distribution curve, let us suppose we have, oops, one plot is something like this, and the other plot it is something like this. Okay, the threshold energy is somewhere here. Okay, somewhere here. Now, look at the blue one. Only this many fraction is having energy that is greater than what? It is greater than the threshold energy. But if you look at the red atoms, so these are the extra parts. Right? Now, what has happened with blue and the red one? If the blue one, we will say this is T1 and the red one is T2. In this case, as you can see, T2 is greater than T1. या आप यहाँ से ही पता लगा सकते हैं. देखिए, the average energy, or I would say that the most probable speed of, or most probable kinetic energy of the T1 particles is here, and for the T2 particle is here. So obviously you can say that the average kinetic energy of T2 is what? It is higher than T1, and also, as we know, the velocity is going to increase if we increase the temperature. So that means we can say that T2 temperature is greater than T1 temperature. All of you got this? Yes or no? Please tell me, guys.
Yes.
Yes, sir.
Yeah. Okay. So what is happening? Whenever there is an increase in temperature, the MBD curve, it shifts towards right. Please write next point. On increasing the temperature, Maxwell-Boltzmann distribution curve shifts rightward. Write a note. As a general rule of thumb, the rate of reaction doubles on 10-degree increase in temperature. Degree increase in temperature. लिख लिया आप लोगों ने इस सोनो पिक्सल में?
Yes, sir.
लिख
Yes.
लिया आप लोगों ने? Okay. So this was all about the qualitative analysis. Okay. Qualitative means कि बढ़ रहा है या घट रहा है, बस उतना बता दिया हमने. और एक we have now a rough idea that on 10-degree increase in the temperature, the rate of reaction is going to double. In the next class, we are going to look at the quantitative analysis of the increase in temperature and also about the catalyst. Okay, so there are two topics that we are going to learn. The quantitative analysis, in which we are going to have formula, and then we are also going to do some numericals, and then the effect of catalyst and how a catalyst is going to work. Okay, and how a catalyst is going to work. Chali. That's it for today, guys. Please revise. अच्छा, आप लोग का तो ऐसे भी एग्जाम है नवार के अलावा रिफत एंड हनीफा का, तो प्लीज रिवाइज द लास्ट क्लास न्यूमेरिकल्स, और आज जो हमने न्यूमेरिकल कराया उसको भी एक बार फिर से रिवाइज कर लीजिएगा. ओके, ऑल्सो हैव अ लुक एट द असाइनमेंट्स. आपको लगता है असाइनमेंट्स नहीं देखते हैं? यस हनीफा, रिफत एंड नवाल, टेल मी, असाइनमेंट देखते हैं आप लोग?
Yes, sir.
हो हनीफा, आपको नहीं मिलता है? आपने लर्निंग को बताया असाइनमेंट नहीं मिलता है,
Yes, sir.
तो उन्होंने क्या बोला?
They said they'll check and then there is no
देखिए
speak.
फॉलो अप कीजिए. देखिए
Okay.
there is one word which you should do always, that is follow up. Okay, Hanifa.
Yes, sir.
Okay, also जैसे मान लीजिए आपने हमसे भी कहा ना कभी, सर आप प्लीज ये शेयर कर दीजिए, और हमने बोला अच्छा ठीक है हम कर देंगे, ठीक है करके हम बताते हैं, ठीक है हम ये कर देंगे वो कर देंगे, फिर आप बोलिए कि कितने दिन बाद हम आपसे फॉलो अप कर ले सर, कि आपको याद रहे या नहीं याद रहे, है ना, वो भी पूछ लिया कीजिए. ठीक है, और यू जस्ट से दैट आई विल फॉलो अप आफ्टर अ डे, आई विल फॉलो अप आफ्टर 2 days, और आई विल फॉलो आफ्टर द हॉलीडे. ओके, ठीक है, फॉलो अप जरूर से क्या कीजिए, लोग भूल जाते हैं ना, लोग भूल
Okay,
जाते
sir.
हैं. ठीक है, चलिए, thank you guys, thank you very much. Okay, we'll meet we are going to meet tomorrow, but I think tomorrow we are going to meet for a while, not completely.